Let's suppose we have the series 1 plus x squared plus x cubed plus up to x to the n minus 1. So what does this mean? This means n is equal to the number of terms, so we have n terms in the series, and n minus 1 is equal to the number of terms minus 1. So the last power of 1, so the last power of x is going to be x to the n minus 1, which is equal to x to the number of terms minus 1. Let's see how we can find a formula for this. Now the first step is to realize that in a sense the sum is almost this sum is almost equal to itself. As you can see, there's something about this sum that shows you that the sum is almost inside itself. There is a recursive aspect to this formula. So let's call s, which is equal to the sum, let's say that s is equal to the sum. So s equals 1 plus x squared plus blah 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 x to the n minus 1. Now let's multiply both sides of this equation by x. So you get that x times s is equal to x plus x squared plus x to the third power plus and so on plus x to the n. Now because you see the last term becomes x to the n because you're multiplying it by x. So x to the n minus 1 times x is equal to x to the n minus 1 plus 1, which is equal to x to the n. So now the second step is to subtract x times s minus from s. So s minus x times s is equal to, now is equal to this sum here minus this sum, so that's equal to 1 plus x squared plus x to the n minus 1 minus the second sum, which is equal to x plus x squared plus x to the n. And now, so if we factorize s on this side, we get s times 1 minus x is equal to, now what happens if you subtract this guy from this? You have an x here and an x here, so x minus x cancels, x squared cancels with this, so you're left with 1 plus, and now this x to the n minus 1 here is gonna cancel with the x to the n minus 1 that is here before this x to the n, and so this is gonna give you, the last term is this minus x to the n, so minus x to the n, so this plus goes out, so this is the result. So this is equal to 1 minus x to the n, and so this means that s times 1 minus x is equal to 1 minus x to the n, and finally s is equal to 1 minus x to the n divided by 1 minus x. So as you can see, we were able to find the sum by just multiplying the sum by x, and that's because x times the sum is inside the previous sum, except for the term x to the n. So the sum itself is equal to minus x to the n divided by 1 minus x. Now this formula is valid if x is different than 1, because if x is equal to 1, then we get a 0 here, and this is undefined. So if x is different than 1, then this sum is satisfied. Now let's do an example. So let's say that x is equal to 2, then the sum is equal to 1 plus x squared plus blah 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 plus x to the n minus 1. Let's say that n is equal to 5, and so the sum the sum is equal to 1 plus 2 plus 2 squared plus 2 cubed plus 2 to the fourth, and 2 to the fourth is the last term because 5 minus 1 is 4. So this sum, if we use the formula, if we use this formula here, then that means that the sum is equal to 1 minus x is equal to 2, so we write 2 here, n is equal to 5, so we write the 5 there, 1 minus 2, so this is equal to 1 minus 2 to the 5th power divided by 1 minus 2 is equal to minus 1, so this is equal to 2 to the 5th minus 1, and this is equal to, now 2 to the 5th power is equal to 32, and so 32 minus 1 is equal to 31. So this is the sum, and if we write down the sum, so we get 1 plus 2 plus 4 plus 8 plus 16, and this is equal to 3 plus 4 plus 8 plus 16, so this is equal to 7 plus 8 plus 16, so this is equal to 7 plus 8, now 8 times 2 is 16, so this is equal to 15 plus 16, which is equal to 20 plus 11, which is equal to 31. So it's exactly the same result. So this is called a geometric series. This is called the geometric series, and geometric series happens whenever you have a factor and you take all the powers of this factor and sum them up. So one interesting thing about this the geometric series is that n here can be infinite, can be an infinite number. So let's write again the sum. So the sum is equal to 1 minus x to the n divided by 1 minus x. Now if n is infinite, that means we have an infinite number of terms here, plus this goes on to an infinite number of terms. Now let's find a condition for when this is true. When can you have an infinite number of terms? This is true only when this sum here is defined, or when this sum is finite. So in order for this sum to be finite, the only thing that depends on n is this term x to the n. So if x is greater than 1, then x to the n goes to infinity as n goes to infinity. So the only chance we have for this sum to converge is if x is between minus 1 and 1. So that's the same as saying that the absolute value of x is less than 1. And this is because the sum is also not defined, so x has to be different than 1. The sum is not defined for 1, remember, because if x is equal to 1, this is equal to 0. So if the absolute value of x is less than 1, then s converges. And this is called the infinite geometric series. So this is 1 plus x squared plus blah 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 goes to an infinite number of terms, and the absolute value of x is less than 1. So that means that whenever x is less than 1, we can get a finite value for this. So let's say x is equal to a half. So then we get 1 plus a half plus 1 over 2 squared plus 1 over 3 squared. Sorry, so 1 over 2 to the 3 plus and so on to infinity. This is going to be equal to excuse me. is going to be equal to 1 minus a half to the n, 1 minus a half on the bottom. And because n is infinite, here's the key fact: because n is infinite, then 1 over 2 to the n goes to 0 as n goes to infinity. So this goes to 0, and we are left with 1 over 1 minus a half, which is just a half, and this is equal to 1 over a half is equal to 2. So this is the sum. So that means that this infinite series has a value, and this value is equal to 2.